Okay, it's going. It is. Okay, this is 1.1 number 8a. And the question says, no, I'm just going through your homework for you. It says, find the point of intersection for each pair of lines and then check your answer. Okay, so they give us the two lines. We have y equals 2x plus 3, and we have y equals 4x minus 1. And they're telling us that at some point, these two lines are going to intersect. So let's say hypothetically we have one line that looks like this, and we have one line that looks like this. We are trying to find this point. Now what's true about this point of intersection is that it has a x coordinate and a y coordinate. It will intersect where those coordinates are the same, right? Or I should say those coordinates will be the same where the two lines intersect. So that means that the y value at the point of intersection is going to be the same for both lines. Now, if I know that this y and this y are exactly the same, they're equal to each other, then this side of the equation 1 must be equal to this side of equation 2. Does that make sense? Okay, so wherever they intersect, it's all going to be equal. Y is going to equal y, is going to equal 4x minus 1, is going to equal 2x plus 3, is going to equal y, is going to equal y. They're all going to be equal where they intersect. So all I have to do is say, okay, since the y's are equal, I know this side will be equal. So what I'm really trying to find is where 2x plus 3 is equal to 4x minus 1. Now I need to use my algebra rules to get my variable x on the same side, and I'm actually going to be finding this coordinate. I'm going to be finding the x value where they intersect. So here we go. I'm going to move my things to the, I'm going to move it to the left. So I'll subtract 4x from both sides. So this side becomes 2x minus 4x, which is negative 2x. And on this side, I have 4x minus 4x, which just leaves me with negative 1. Now I need to subtract 3 in order to isolate my x component here, the term with x in it. I need to subtract 3 from this side, and I need to do the same thing from the other side in order to keep it equal. So on the left, I'm left with 2x, negative 2x, and on the right, I have negative 1 minus 3, which is negative 4. Now to get x by itself, I just divide both sides by the coefficient. The coefficient is the number that's in front of the variable. So the coefficient here is negative 2. I'm going to divide. Yep. So, but right now I'm dividing it by. This is addition. So it's negative 1 minus 3. Yeah. Now I'm dividing it negative by a negative, so it will become a positive. So all I'm left with here is x equals negative 4 divided by negative 2. It's the same as 4 over 2, which is 2. Now I know at the point of intersection, the x value is going to be 2. But I'm not done yet. I need to find the point of intersection. So that means I need an x coordinate and a y coordinate. So all I have to do is I can have equation 1 and equation 2. I'm going to sub this x value into equation 1. So now y is going to equal 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. So this tells me the point of intersection is the coordinates 2, 7. But it also says check your answer. How do I check my answer? I put it in the second equation. So this was equation number 1. Now I put it in equation number 2. I'm going to get y equals 4 times 2 minus 1. 4 times 2 is 8, minus 1, 7, checked. And I also then need to have my answer in my final answer. So the coordinates, this is a bit, you guys won't run out of space because you won't be going side to side like I am. just do it vertically. But the coordinates here then are 2, 7, point of intersection. Good? Whole problem. So for 9a, I'm not going to do the whole problem. It's very similar to 8, but it says find the point of intersection for each pair of lines. Check your answers. But this time, the lines are not given to us in standard form. They're not given in y equals mx plus b. We have the line x plus 2y equals 4, and we have the line 3x minus 2y equals 4. Equation 1 and equation 2. So let's get equation 1 into standard form. Equation 1, I'm going to subtract x from both sides. So I'm going to be left with 2y on the left and 4 minus x on the right. And now I need to divide both sides by 2. Divide each term by 2. It's going to leave me with y equals 2 minus, this is the same as 1/2 x. So if you take x and divide it by 2, right? Let's say this is x, and you're going to divide it by 2, you're left with half of x, right? So this is 1/2 x. Good. Equation 2. Again, we're going to get y by itself. So I'm going to leave y, well, yeah, we'll just subtract 3x from both sides. So we'll be left with negative 2y, don't forget about that minus sign, equals 4 minus 3x. Now I'm going to divide all the terms to get y by itself. I'm going to divide all the terms by negative 2. So here we're left with y, right? Negative 2 divided by negative 2 is 1, leaves us with 1y. 4 divided by negative 2 becomes negative 2. And then I have, there's two ways you can do this. You can either assume that this is negative 3x, in which case you'll have a negative divided by a negative, resulting in a positive, or you can leave it as a minus sign, and then you'll have positive 3x divided by negative 2, which means you'll have a negative. I'm going to do it that way, just so that you can see it. So I'm going to keep my subtraction sign in here. Then I have 3 over negative 2, which is negative 3 over 2x. Not quite done here. We have a negative. We're subtracting a negative. Subtracting a negative is the same as adding. Okay? So we're going to have y equals, I'm going to switch my terms around so my x term is first. 3 over 2x minus 2. Equation 1. Equation 2. Now I can find my point of intersection by setting equation 2 equal to equation 1 and work it out the same way we worked out number 8. 1.2, the method of substitution. The method of substitution, this is solving a linear system by substituting for one variable. This will make sense after we do a couple. Substituting for one variable from one equation into the other equation. Okay, so we know in a linear system there are two equations of a line, and we want to find out where they intersect. One way to do that is to use the method of substitution. Okay, So we're going to look at example number 1. I'm actually going to start at the top of my page whenever you guys are ready. So example 1 asks us to solve using substitution. Am I good to clear the rest of this? The lines that they give us are y equals negative x plus 8 and y equals, sorry, not y equals, and x minus y equals 4. It tells us that these are going to intersect at a right angle. What does that mean? Yeah, exactly. They're going to be perpendicular to each other, either like this or like this or like this or like this or like this. Is that relevant for us to find out where they intersect? We don't care how they intersect. We want to find out where they intersect. So that's called extraneous information. It's information you don't need. What we need to do is find the coordinates of the point of intersection. So our first step, as per usual, is we are going to label our equations. We have equation 1 and equation 2 in order to help us keep track of them. When I'm recording, I don't have that option. It's an auto zoom camera, so it automatically zooms. When I'm in the Windows camera, I can set it to manual, but when I'm in Windows Movie Maker, I can't set it to manual, which is really frustrating. I know I need to get a different camera. Sometimes if I try and keep my hand there. Okay. So step 1, equation 1 is in the right form, right? So we can substitute negative x plus 8 into equation 2 for y. And this is essentially what we've been doing. If we know that y is equal to negative x plus 8, then we should be able to substitute this for y wherever we see y. It's equal to y. So we can take equation 2, and instead of it being x minus y equals 4, wherever we see a y, we can substitute negative x plus 8. So let's go ahead and do it. We have x minus y, and we're going to put y in brackets now because y is negative x plus 8. It's still going to equal 4. Are we good there? All we did was we knew that y was equal to negative x plus 8. So wherever we saw y, we plugged in negative x plus 8 instead. Substitution. If they're equal, you can substitute them. No big deal. And now all we have to do is some simple algebra. A little trick here is that this in front is a negative 1. So we're minusing this, whatever's inside this bracket. We're minusing 1 of whatever's inside this bracket. But what we also have talked about, did we talk about distributing on the first day of class? We did some distributing. Okay, so I need to distribute this negative sign, which is negative 1, to both of the terms inside the bracket, to both of the terms of the binomial. Okay, so I have x here still, but now I have negative 1 times negative x. Negative times a negative is a positive. 1 times x is just x. So we have positive x. And I have negative 1 times 8. That's negative 8. Okay, so when you're distributing, this is a little bit tricky with the negative out front, but it basically just means change the sign of both of these things. Do you see that? The negative told this negative to become positive, told this positive to become a negative. But what we really did is we multiplied both of these terms by -1. Okay, I'm going to continue. Simplify this, and I'm going to move 8 to the other side by adding 8 to both sides, right? So if I put these two x's together, I get 2x. And if I add 8 to both sides, I get 2x equals 12. Now I can divide both sides by 2. And x equals 6 at the point of intersection. So I added 8 to this side, and I added 8 to this side. Yeah, good question. I'll try to keep doing those in between steps. I'm trying to kind of phase out little things along the way, but I don't mind to continue doing it. Okay, so now I have my x, but if I need to find the point of intersection, the point of intersection has coordinates, an x coordinate and a y coordinate. So Gavin, what do I need to do now? I've got an x value. I need the y value. How do I get it? Good, so step 2 is substitute my x value into either equation 1 or equation 2. Doesn't really matter. I'm going to use equation 1. So you can keep going sideways, down. I'm going to move just off to the side here. Another way you can do it is if you do a whole thing down and you're doing kind of a new section like we're doing now, you could like leave a space and then start a new section there if that helps you not use so much space. It's up to you. But I'm going to sub it back into equation 1. So I have y equals -x plus 8. I know that x equals 6. So I have y equals -6 plus 8. -6 plus 8 is 2. I'm going to double check that answer by subbing it into equation number 2. Equation number 2 was x minus y equals 4. I know x is 6. And I'm going to bring y, subtract y from both sides. So I'm going to also subtract 4 from both sides at the same time. Okay? I'm going to do 2 steps here. I'm going to add y to both sides, and I'm going to subtract 4. So this side is 6 minus 4, which is 2. And this side is just y. Y equals 2. So that's checked. I know that's correct. Now I need to write the conclusion. The point of intersection is 6, 2, period. Example 2 again asks us to solve using the method of substitution, but this time we need to rearrange our equations in the linear system. So we need to find the solution to the linear system that includes the lines x plus y equals 5. Call that one equation 1. And equation 2 is 3x minus y equals 7. Neither of these equations are in the form y equals mx plus b. So in order to substitute a value for y, I need to have at least one of them in the correct form. This one has a negative y, so I'm not going to work with him right now. I'd rather just on this side, I can see I just have to subtract x from both sides, and I'll be in the form y equals mx plus b. So always pick the one that's easiest. All I have to do here is subtract x from both sides. So here, y equals 5 minus x. Not 100% sure what you're asking, but basically x could be any value in the whole world, and this will still make sense. This sentence still has to be true. That means that the value of y is dependent on what x is, right? If x is 4, then y has to be 1. If x is 100, then y has to be negative 95. So y is always dependent on x. This sentence always has to be true. So in order for it to be true, I have to do the same thing to both sides. So if I'm subtracting x here to get y by itself, I need to subtract x here to get y by itself, to be fair. So remember, x is a value. X might be 3. Then you do 5 take away 3 is 2. And y would be 2. You don't. It's all of the values of x because it's a line. So at every single value of x, there is a value of y. Does that make sense? We just don't know what they are specifically. That was when we were dividing x in half. Remember, that was when we had x divided by 2. So then I just said, let's say this was x, and you divide it in half. Now you only have half of x. So that just meant this was the same as x over 2. But here we're just subtracting a whole x, whatever x is. If x was 7, we'd be subtracting 7. If x was 20, we'd be subtracting 20, but we don't know what x is. It's the variable. Variable means it could change. Okay? Which is why it's possible to make a line. So this line has an infinite number of points. All of these x values result in some y value. Okay, so every single x value results in a y value. It just so happens that in a line, in a linear system, a linear relation, all of those points, those infinite number of points, we draw more points and 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 more points. What do they start to make? A line. Does that help a little bit? It'll all start to make more sense too when we start seeing them in graphs more often. But for now, I'm going to rearrange this. I'm going to subtract x from both sides like we had. So I'm left with y equals 5 minus x. Now I can substitute if y equals 5 minus x, then where they intersect, y is going to equal 5 minus x. And this y is going to be the same as this y. So take equation number 2 and go ahead and sub in for y 5 minus x. Nadia, what am I doing next? Yeah, I need to distribute this negative to both of these terms, which basically just means that instead of positive 5, I'm going to have negative 5, and instead of negative x, I'm going to have positive x. I'm going to have the opposite, right? The opposite of what they gave me. Still equals 7. You don't have to put the 1. Actually, you shouldn't put the 1, but it's just helpful sometimes to help you realize that this minus is like you have this bracket once. You have one of these brackets. So you're distributing negative 1 to both of these terms, multiplying both of the terms by negative 1. Vanessa, what would be my next step here? I noticed something about the left side here. Yeah, I have an x term here and an x term here. they can go together. 3x plus x is 4x minus 5 equals 7. Gavin, what is next? Remember, I'm trying to solve for x. I want to find out what x is, where they intersect. Right, I want to get rid of the negative 5, and by doing that, I'm going to add 5 to both sides. So plus 5 here, plus 5 here. This becomes 4x equals 12. Amy, what's next? Divide both sides by 4. 12 divided by 4 is 3. So the solution for this linear system is x equals 3. But I want to find the corresponding y value to make sure that I've done it right. Okay. So here we go. To find the y value, Nadia, what do? I'm going to take equation 1, and I'm going to sub in my value for x. So I end up with 3 plus y equals 5. Sarah? What do? Yeah, I want to get y by itself. I want to see what y equals. So subtract 3 from both sides. So remember, we kept it equal. We made sure it was still true. So you can use it in any form you want. If you wanted to use this one, I probably would have used that one if I had seen it. I missed it. But yeah, that one, of course, is easier to use. 5 minus 3 is 2. That's what we got here, too. Okay, good question. If a statement is true, and then you kept it true, you can use whatever one. They're both going to be the exact same. But yeah, you're right. We made it easier on ourselves, so why wouldn't I have just used that one? I'm going to double check the answer in equation 2. We've got 3x minus y equals 7. X is 3. I'm just going to do it quickly. So we have 3 times 3 here. This becomes 9 minus y equals 7. I'm going to subtract 9 from both sides. Negative y, 7 minus 9 is negative 2. And, well, negative y equals negative 2. That's easy. Y equals 2. Yeah. So Sarah's asking, if you got into a situation where you had negative y equals 2, and you had to find out what y equals, you would just divide both sides by negative 1. Or times both sides by negative 1. And then you'd be left with just positive y equals negative 2. Okay, so we've confirmed our x and our y, our point of intersection, but we don't want the coordinates this time. This time it didn't say find the point of intersection. It said solve. So when we solve, we want our final answer to be the solution to the linear system is x equals 3, y equals 2. It's the exact same information as coordinates, but it's written differently. Okay, a solution is in the form x equals something, y equals something. The point means you're talking about specifically where are these lines going to hit on the graph. They're going to hit at the point x, y, right? Coordinates. Good. We are doing okay. Oh, sorry, did I erase too soon? So here we go. Example 4. Stephanie has 5 more fish than Brett. The two have a total of 31 fish. How many fish do they each have? So in order to solve this, they give us enough information for two equations. Okay? Let's set up some rules here. We're going to let S be, we're going to let S represent Stephanie. And we're going to let B represent Brett. Now we need two equations. And the first equation is found in the first sentence. Nadia, could you put that into an algebra sentence for us? Stephanie has 5 more fish than Brett. Yeah. I'm going to write it B plus 5. If Stephanie has 5 more than Brett, then S must equal B plus 5. The second sentence gives us other information. The two have a total of 31 fish. Amy, can you put that into an algebraic sentence for us? S plus B equals 31. Okay, so we want to use the strategy of substitution. So, Ness, what is the easiest thing I can substitute here? Yeah, I know for sure that S equals B plus 5. Right here, I have an S. So wherever I see an S in equation 2, I'm going to call it B plus 5 because I know it's the same number. Okay, S is the same as B plus 5. So I got B plus 5 plus B. Good. Go ahead and finish it out. Find B. Go for it. Once you found B, you can go ahead and find S. Do you have what I have, Ness? But do you have this? Like, is this your first step? Okay, so then all we did was we have a B here and a B here. So that's 2B, right? 2B plus 5. Now we want to get the B's by themselves. So how do we do that? Yeah, I'm going to take 5 away from both sides. So you have 2B equals 26. Good. So then all we need to do is divide both sides by 2 in order to get B by itself. Okay, so hopefully you got that B equals 13, which means that Brett has 13 fish. And you can use that information, sub it back into equation 1 to find out what S equals. If S equals B plus 5, then S also equals 13 plus 5. and Stephanie then has 18 fish. Now we want to look back. It's one of those hanging timers. Yeah, you can go get it. So now we want to look back to make sure that that all makes sense. Okay, if we sub in,
Do we have to check it every time?
how do you know that you got it right if you don't check it?
Does it make sense?
How do you know it makes sense?
Because there's like the equation and the thing. Like, just look at it.
Right, because in your head, you checked it.
Yeah.
Okay. So all you have to do is quickly write down S is 18 plus B, which was 13, equals 31. Yep, that's checked. Okay, that's all it takes. And because it was a word problem, you will need a final statement for your answer. So look back at the question. How many fish do they each have? Stephanie has how many? I sure don't. Stephanie has 18 fish and period.
No. Yes. No.
I always did that. But you don't have to do that in this situation. There are certain branches of math where you must do that. This is not one of them.